Okay. Oh, that means your WA will involve pressure as well.
Yes.
So you didn't bring the homework from last week, right? Did you? No.
I remember. Sorry.
Okay, then. Let me just go through some revision with you. Or even, oh, I'm not feeling that well also. So suddenly got this sore throat. I may have to use this.
Sorry. What it's called? We just India, and then I throw a few.
Is it Los Angeles?
Yeah.
Yeah. Imagine eating one now. Not as good as it should be. Okay, let's go to the pressure part first. Because I want to finish one more formula with you.
Oh, yeah.
Yeah, just for you only. Oh, where's my? Give me a moment. Yes. 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 Yes.
Did he come yesterday?
No, he didn't. He's apparently sick. He said it's what, flu, sore throat.
We go for 2391.
Yeah, I don't know. I think he has quite a few medical issues. Yeah. Oh, hold on, this one is hanging. Let me restart this one. Okay.
That GX.
Well,
But
can't remember something that he doesn't need to do. Something, tell me what are the formulas for pressure?
apparently it was force over area.
Force over area, okay.
Then there's the density. G.
And density G and N.
I can't remember.
Okay. This thing is so slow. Okay, while waiting for that, let me just write down about 3 formulas for you in terms of pressure. Now, this one works all the time. But more often than not, for your case, it involves solids. Not all the time, but often. Now, second one, if you see fluids, and hopefully you know by now,
Liquid gas.
okay, liquid or gas, and this one you apply.
That was close enough.
Yeah, but you still can't get any marks.
Because of the hand.
And I would say the only thing to be careful of is your units Pascal. All the units need to be consistent.
Then if they give that like some other unit that convert.
Yeah, that is the problem. So look at your question. If your question wants it to be in, actually I can tell you, there are only 2 units for you. The other is this one. Now, if this this is the one, is then quite troublesome. Because it's quite troublesome. Let me think. Because this one you have to be in. Okay. And this, maybe I should rewrite it. Otherwise you get confused. Look at your question. Because if this is these are the units for pressure, then likelihood that this will be the units for your density. And this will be the units for your height.
Okay.
But as I'm not finished yet. Now, what are the units for G?
N.
N per kg, right?
Oh.
So you have to do something else. You have to get rid of this kg. All right, so basically,
Times kg.
yeah, 1 kg is 1000 grams. More like divide by 1000.
Okay.
Yeah, it's quite painful, no? It's quite painful. So be very careful. For me, if I would prefer to work with SI units, it's always correct. Your formulas are all, you put everything in SI units, it will always be correct.
Then if the question about ask answer unit, no need convert.
You see, it's quite dangerous, no? Because if you don't use SI units, your formulas do not work as they are. Yeah, that's a troublesome part. Every single formula works only if you use SI units.
Hey.
If you don't, then you have to do something extra, like this one. But you may forget to do that something extra there.
Use mark. Use mark.
Oh, yeah, of course. Okay, so there's a third formula. But since this one is ready, I'll just use the green here. Okay, no, it's still hanging. I can't move it around. This is okay.
No.
No, this hanging also.
Thank you, guys.
No, this hang.
Oh.
Let me see if I can get it to work.
They're close to thing.
Yeah,
Or you lose everything.
I should not. I try. But your WA, does it include pressure? I can't remember. No, right?
Hang on. Doesn't affect.
Oh, okay, okay.
No pressure. Oh, I messed up. It's not. It's doing something.
But it's okay, I just covered this last formula with you.
Okay.
Because they don't need to know it. Even the combined size, they also don't need to know it.
That's anyways. The QA is very better.
Oh, QA is supposedly easier, right? Easier than AMath.
Right. They say QA is 3 marks.
Ah,
Ah. He said don't even need study. Just know what to do and then can get marks.
so good.
I should have went do that. Can't change class, right? Once you
Oh, it's too late already. Now it's already what? Coming to May.
Yeah, so what would be what I always
Oh yeah, just give it your best shot, right? Okay, this one. This is the formula you need to know. Hydraulic press formula.
I'm gonna use it. I'm gonna use it.
It's going to come up for you. For you. Only for you. Okay, come. You myself right now. I think I showed it something similar, right? Remember you have this something like this.
Oh yeah.
Okay, this is what they call hydraulic press. I think for you the key is this area here.
Yeah.
And this area here. Yep. But what else? You apply this force here, and then the force will be exerted on the right hand side. Okay, so the trick is this. The trick is make sure A2 is greater than A1. Therefore, your F2 will be greater than F1. That is the trick. You know what? How this is applied? Because let's say you use your foot to press down, you are not that strong. But when you press down, your area is small. But on the other side, the area is very big. Just by your foot alone, you can lift up the whole car.
Oh yeah.
Okay, that's the important point. But that's not all. I haven't shown you the formula yet, by the way. The formula actually is here. Do you remember work done?
Yes.
What's the formula for work done? Yep, good. Yep, good. So what happens is this. Now, this part will move a distance downwards, of course, right? So yes, D1. Let's call it D1. And of course, this side will also move a certain distance upwards. Let's call it D2. All right. Then I use the work done formula. Do you notice? Work done formula. So whatever work is done here, the work is transmitted to the right-hand side. Right? You notice the force, distance, force, distance. Okay, so now I come with this formula. I hope you notice this is the left-hand side. This is the right-hand side. Okay, based on my diagram. Okay. All right, so this one is getting a bit slow. Then look at the force. Force is also pressure times area, right? Remember?
Oh,
Okay, you can say no.
you mentioned before.
No, not in this form.
Oh,
I mentioned something similar, but not in the final formula. Oh, I haven't shown you the final formula yet. But now you agree, right? Force equals to P times A.
yes, yes.
Mm. That is why I can write something like this.
Oh,
Mm.
equal then where got work done?
Oh God, I know. Work done from the left is transmitted to work done on the right.
What?
Because of the fluid. That is the key. And then finally, but you also know that because these two, remember, they are at the horizontal level. They started at the same horizontal level. So meaning what? Pressure here equals to pressure there. Okay. Then you go back to the formula earlier. What do you see? Can I cancel off P1, P2?
Because they're the same.
Yep. So what is left?
Yeah. And yeah.
Okay. So this is what you need to know. This one. This is your third formula.
Area one.
Yeah, area one. But just be very mindful for D1, it is a downward movement. Whereas for D2, it's an upward movement. Hannah. So that is your third formula. So look out for hydraulic press in your question. They will have it somewhere. Man. Yeah, that's all. That's all. Okay, now chapter 1. What formulas do you have?
That which one? That's the one what?
Measurement, quantities, units.
Oh, I remember the index form. No, index standard.
The which one?
No, it's the millimeter and all those are. Those come from.
No, they are not. They are just prefixes.
They know what?
Yeah,
It's velocity chapter 2.
it is.
Then what is Then why is it shut down?
No. This is basically lump up everything together. I think chapter 1, there's perhaps one formula for you to know, even though it's no big deal. It's the period. Make sure you know what's period.
Oh,
So what is period?
oscillation.
Mm-hmm.
Time taken to for one observation.
Okay, good. Time for one oscillation, huh?
Okay.
Okay, hold on. I forgot to share. So look up for your question. Your question is typically not going to be one oscillation. It's going to be 20, 30, 40. Make sure you divide by the 20 or 30 to get the period. Because your time for, let's say, 20 oscillations. So make sure you take the total time divided by 20. I think formula-wise, speed should be okay, right? Speed.
Speed. Well, speed the same thing, but basically. Acceleration B minus mu over.
But what I want you to be careful, velocity can be negative. But speed is always positive.
Yeah. So wait, no, time cannot be negative. Something very fast.
So take note, speed is always positive, velocity can be negative. And what does it mean if it's negative?
Behind the start.
Yep. That means it's going in the reverse direction. So likewise, displacement can be negative too. But distance is always positive. Okay. Displacement is behind the starting point, but if it's negative, but velocity negative means it's moving backwards. Okay, this one is quite complicated, but it can come up for you. So this is the starting point. So let's say if you are here and you're moving like this. Okay, so in this case, your displacement is positive. Velocity is also positive. Okay. But let's say if you are here. You are here. But you're moving like that.
Oh.
Then your displacement is positive, right? Because you're still on the right hand side.
Okay.
But your velocity is not. Because you're moving backwards.
Right this down.
Make things worse.
Yes.
If you are here, then there is a net force acting here.
Oh,
like friction. So, is the acceleration positive or negative?
still moving.
Yeah, it's still moving. Velocity is not zero. As long as it's not zero, it's moving.
Not constant.
Yeah, it's not constant.
That means acceleration is increasing. No way.
Shit. Okay, remember this formula.
When is the 10 minutes?
Okay, very simple. Based on this formula, if net force is positive, A is positive,
Oh,
right? Because M cannot be negative, right? M.
wait, it cannot be zero also.
Well, yeah, it cannot be zero too.
Okay.
So that's the thing you need to know. If this is positive, this is positive, this is negative, this is negative. So back to here, is my net force positive or negative?
Yeah, it's positive.
Why? Now, you see, look at the whole movement. Anything that is from left to right is the positive direction.
Then you have the
Yes. Yeah, that's why I said that velocity is negative, because it's moving backwards. Oh, but yet it is still on the right hand side of the origin, so the displacement is positive. But for this case, if this guy is moving to the right, yet there's a net force acting to the left. So net force is negative now. Huh?
yeah. That means it's this set. Decelerating.
Yes, good. That means acceleration is negative, which also implies deceleration. It's
Yeah.
slowing down.
Then it's accelerating and go faster.
Yeah. Complicated, right?
I don't think.
It's okay, you get the hang of it. I mean, see, here I just don't care. Let's say you're this guy, and for some reason you have a net force. Something is pushing you to the right. So how? Acceleration? Positive or negative? Hmm?
Negative.
Net force is positive.
Positive.
And because it's going to the right, so it's positive. So positive means acceleration is positive too.
So acceleration is the way.
Yeah. But normally you have to define it yourself. That means from left to right is counted as positive direction.
Okay.
Okay, so okay, I hope I make it clear. 1, 2, and 3, they may not be related. So this is positive, doesn't mean this is positive, doesn't mean this is positive. They can be separated. Okay. Okay. I think the gradient area under the curve, you're okay, right?
At least reverse on that.
Revise a bit.
Yeah, on that.
Okay.
I forgot.
Hmm.
I'm not gonna write it down.
Okay, but try to follow. First thing first, check your axis. Alright, because for you, they may give you a distance time. Or they can give you displacement time, which is what? Troublesome. Or give you speed time. Or yes, got it. We give you velocities time.
Yeah.
And very, very occasionally, oh, that's the worst.
What the variation?
Yeah, that's the worst.
Never see before.
Very rare, very, very rare.
Yeah, so it's speed becomes velocity determinant. I don't know. You know distance, right?
No, come, let's look at it. Don't worry. First thing first, remember distance is always positive, always.
Yeah.
Always, so it cannot go under here. It must be above her. And not only that, distance is increasing. In other words, for distance time, you will never see like that. If you keep on increasing, or stationary, then increase.
You cannot go this way.
No, it cannot be a negative curve.
Okay.
And it cannot, of course, cannot go below your x-axis either. So anyway, very simple. And then, hopefully help on the graph.
Not straight.
That means
Not constant.
not constant, but
And speed.
good. Remember, distance tells you speed. So the speed is not constant. Speed, increasing speed, increase again, decrease and so on. Area under curve, don't bother. It doesn't tell you anything. How about this? But this one is difficult. Oh, I can have this, no? I can have that, no? Displacement can be negative, huh? It can be increasing also, huh? So what does it mean?
So from here. Oh shit, one minute. Wait, let me think a bit. Yeah, it reached the starting, then you go. That. Oh, yeah.
At which point is it starting to reverse? Start from zero, right? Zero is here, right? So it go to the right. Then at this point, it reverses. And then at this point, it go past zero again. And then as it goes downwards, it continue back.
Yeah.
What else? Notice this is positive gradient. So meaning what? Positive velocity, right? This is negative, right? Because the slope is negative. So positive velocity means it's going to the right. Negative velocity means it's going back to the left.
Okay. Yeah, so it's not the gradient. Is there anything for the gradient?
Oh, yes, of course.
Distance man, more.
Okay, one last thing.
Oh.
Yeah, okay. So if there's, oh, but of course, as I said, just now, speed is always positive.
Yeah.
But tell me, if I show you something like this, what is it?
Speed increasing.
Increase and decrease. Eventually, it comes to a
Stop.
when it's zero, it means it's at rest. Okay?
Yeah.
Yeah, that's all they have. Increasing and decreasing and then stop.
Suddenly.
Oh yeah. So, oh, by the way, before I forget, This is positive, right?
Oh, yeah.
Positive acceleration. Negative acceleration.
Okay, so it's like this one. Then this one be okay. Then this is velocity timer. So it's like from below it come on. Is the acceleration positive?
Okay, so it's not you drop what? Drop
Like from here,
you drop first, you drop.
somewhere.
And it can be anything for velocity. So this one, positive or negative radius?
Negative.
No.
No.
Oh yeah, sorry, yeah, you're right. You're right, because of the negative radius. So it's negative acceleration now, right?
Okay.
But what else? Positive or negative velocity?
Negative.
Negative velocity, yeah? Good. What's the meaning? Negative velocity means is
Time and stuff.
no, that's for displacement. Negative velocity means it's moving backwards. Backwards, huh? But it's also negative acceleration, no? That means there's a force pushing me backwards, right?
Which? Oh,
Negative acceleration is negative, force is negative pushing me.
this object move this way.
In this case, there's a force pushing me backwards, huh? But velocity is also negative, so it's also moving backwards, huh? So it's not all, that means it's accelerating backwards, huh? Make sense?
Okay. I think the more I ask, the more I get confused.
Maybe. Now, let's give one scenario. Let's say you are this guy. Now, velocity is positive, acceleration is negative. What does it mean? It's moving left or right?
Moving this way.
Good. What else? Acceleration is negative. Yeah, you're right, moving this way, but it is also. Acceleration
It's going down.
Yes, good. It's going here, but it's slowing down. Okay, but on the other hand, if you are this guy, velocity is negative, acceleration is negative. What does that mean?
I do that.
Mhm.
Backwards.
Yes, backwards. There's a force pushing backwards as well.
So it's better.
Yes, it's accelerating backwards.
You call that deceleration?
Not exactly, because it's moving in the same direction as acceleration.
So what do you call it?
Accelerating backwards,
Oh.
which is what's happening here. Right? But what else? This one? Positive or negative acceleration? Good. Positive or negative velocity?
Negative.
Velocity, no? It's under the x-axis, right? Zero is here, right?
Right.
So it is. Right, it's below the x-axis, so it's negative. So what does that mean? It means it's moving backwards because of the negative velocity, but there's a positive force now pushing here. So as it moves backwards, it's slowing down, slowing down, slowing down, right? Until here.
It's got
Then it stops. Good.
thing.
Then it moves Positive, negative acceleration?
Both positive.
Good. Yes, you're right. It move backwards, slow down, and you stop. Then you move forward again. And you speed up. That's the stop portion. And but if you add in area,
Area under the
what's the area? Area means
distance.
the distance. Yes, this one is half
Why is it?
because this is displacement.
Oh, yeah.
Yeah.
We find area to be as right negative.
Yeah, so basically it's still negative displacement, so that means it's still somewhere behind here. All right. And but be careful, this is negative displacement. But if you look at this part, this is positive displacement.
It comes as area.
But hopefully this will not come out. This is very difficult. Very difficult.
Oh,
Yeah, hopefully it doesn't come.
if it does come out, how? My physics still mentioning that she's the one setting it. She's probably gonna make it hard
Okay.
because she wants. No, actually not because she wants to. She says like, no.
Of course, this is the worst one. For me, I think this quite.
Oh, even it's like gradient. There's no gradient.
There's no gradient. Gradient doesn't tell you anything.
Then, the area also doesn't tell you.
Because that is the difficult part.
Velocity.
Yeah, it tells you velocity. But I hardly see it coming out.
It come out over. Okay, good.
More for those elite schools like RV, they may come up with a question like that.
Yeah, no worry about it. It's not like us. But they might do it because they want.
Yeah, maybe. They want to emulate the elite schools.
They are so trash.
So yeah, that is kinematics. But like I say, kinematics only has one formula, this one here.
Oh yeah.
The rest are just graph work.
I don't know. What did it feel?
Okay, other than that, for forces, this is the formula you need to know. It will definitely come up. The only thing I want to remind you before you use this formula, make sure this is your net force. Don't anyhow throw in a force there. Because if there's no net force, there's no acceleration.
Oh.
Of course, related to this formula is the weight formula here. Yeah, it looks like this, right? Because W is a force now. So G is the acceleration. Density should be okay, right? Yeah, just make sure your units are all correct. Moment should be okay too, I personally think. Now, just make sure your distance here is the perpendicular distance, right?
Oh yes.
So if I have something like this, You got something here. Where's the perpendicular distance?
I don't know.
Yeah, you have two forces.
What? Perpendicular distance.
Mhm.
What is it? No. It's
Three. It's perpendicular to the force.
oh my god, you remember that?
Yes, this is a common mistake. This is the distance you want, not this one. Okay,
Okay.
same thing, of course, this applies to the right hand side too. This is what you want. Okay. But let's say in this case, is that equilibrium?
No.
Of course not. Yeah, there's a net clockwise movement. So you keep on turning to the clockwise.
Oh yeah. Yeah.
Okay, don't get tricked with this.
Yeah.
Oh, but okay, another question that I'm pretty sure they will ask.
What a fast thing.
No, yeah, okay, maybe.
Fast one. Maybe.
Possibly, but this one. They will tell you that this system is in equilibrium. Which force is greater?
I use the formula.
Yeah, but can you see from here?
No.
Huh?
Then you give at least some shit, right?
You can pretty be sure that this distance is much larger than this.
So you can use any random number, just like two average plus.
You can.
Oh. They won't even give you any value.
No, sometimes they don't give value. They just show you a diagram.
That's dumb.
Impossible. You think your school is not dumb?
My school is stupid.
Yeah. Which is a
So larger distance or more.
system in equilibrium, huh?
No.
So which force is the greater one?
This one?
Yes. Make sure it's not there, huh? Make sure you can
No,
understand.
yeah, I get it.
Yeah.
I get it. I just don't know how to get it.
Because these are all common mistakes. I mean, students have all made all these mistakes before. CG, just remember stability depends on the CG. So the more stable it is. Okay, what's the position of CG to give you stability?
Either.
Okay, but you also want it to be as low as possible. What else?
Okay.
What's the second factor for stability? Wider base. Okay,
Right.
so essentially, you do not want to have this situation.
What?
Let's say, okay, let's look at the bus again, huh?
Oh. How that goes.
Now, basically, if the CG is here, you're in trouble because it act vertically down. Maybe they overload the second deck.
That we go.
I think so.
Okay.
So what is happening is the weight is acting outside the base now.
Oh yes.
That's what you have to remember.
I remember this now.
So on the other hand, if my CG is here, then I'm perfectly safe because my weight is still acting within my base.
Okay, this is plan.
That means you have to shift whatever heavy stuff to the lower deck. Okay. What else? Let me stability. That's about it, no? Yeah, that's about it for your WA. No energy, no pressure, right?
So principle of moment.
Oh, that's the equilibrium principle. So that means if I have this system here,
But why this ACW? More force.
So 4 forces.
Oh, wait, yeah, okay. And then, over here,
Well, not exactly. Look carefully. This is clockwise and anti-clockwise.
okay.
No, not just right or look at left or right.
Hoping a drum circle. No, wait, I'll figure it out.
Like that.
Right, it's equal drum.
So which is clockwise, which are anti-clockwise?
This is anti-clockwise. And this is. Hey, wait, what am I saying?
Carefully.
Brain fart. Okay, wait. Okay, so this one is these three are anti-clockwise.
Good.
This one is clockwise.
So how does the equation look like?
You write the thing first, then you write out the equation.
So essentially, if I write it out clockwise, it has to.
It's supposed to write that.
Right. Reminder, make sure all these distances are perpendicular distances. Because they may not give you such a nice force. No? Let's say I throw this in.
Wait.
Oh, okay, a weight is another thing. Now, let's say I throw this force. This looks like this.
Hey.
F1, this is F2, F3, F4. How? Where's the perpendicular distance?
No.
Huh?
Wait, perpendicular.
Yeah.
Yeah.
Ah, you mean here?
Perpendicular. Hey, it's straight line. Is it right angle?
You mean like that?
Ah.
But remember the distance is to the pivot, no? Where's my pivot?
How is it perpendicular?
So, and to be super careful.
Hey, wait, was that one?
Why not?
Hey.
This is your perpendicular distance.
This car.
This one. No, this one is not counted. This is the one I'm interested in.
Oh. Okay.
Yeah. Oh, lastly, don't forget. They will tell you that this guy has a weight.
Oh, yeah. Wait, it's down foot.
Where's the weight? Right in the middle. And of course, weight is always down.
Yeah. Oh, you draw the yeah.
So you have to input the weight. Is it clockwise and anti-clockwise?
It's clockwise.
So you add on this side, clockwise side. Of course, the distance is this one. It should be quite straightforward.
Oh, I should take also.
Mm.
Iman. Yeah, okay.
So yes, that about covers it. Not too bad, right? Just a few formulas only, right?
It's hard to remember this. You not from the person with the question, right? It jungle.
Yeah. Oh, I give you a worksheet just to let you try out.
I go buy OT.
Oh, you go first.
Thank you.
That's simple revision. Just a few questions for me.
Yeah, was this from a past year paper?
Yeah.
The format is like the bro. It's from the school form of C1.
Huh?
They put them C1.
Yeah, it's not, but not your school.
You say all the schools. Or if you didn't know.
Oh, there is actually.
Hey, yeah, please. Then it is a also shape.
Yes.
Yeah, it's one. This one is strong, man. Primary six.
Huh?
Primary six all the shape.
Yeah, yeah. Eh,
One thing.
it's waste of time, I find. Think you are done already, I erase.
From tape over.
Have you?
Very.
Okay. So now.
Wow, I forgot how to read this. Oh, no. Oh, no way.
Okay. Good news, this one will not come up. It's taken up from the syllabus already.
Let's go. But do I still?
No need, your teachers didn't teach, right?
No.
Yeah, then it's taken out already.
They'll digital.
Yeah, only the set 4 need to know this.
Yes. But then they also got add in like the others. My syllabus, right?
No, for you, they add in the radioactivity. It's a totally new chapter. Totally new one.
What does that do with people?
Why not?
More.
Well,
Yeah, I think more can.
it's not chemistry, chemical reaction, it's nuclear reaction, so still counted under physics.
Learn about that for what? No what?
Yeah, lor. Like figure out how long does it take for the radioactivity to die down to safe level.
Oh,
Uh,
it's my next hand. Oh.
Oh, yeah, it's fine. Yeah, the other thing is appreciate. Very common. That's exactly. Yeah, it's very cold. It's like here is warm, you know. Really? Yeah, it was raining, right? It's very, very cold. I think it's okay. Here we can't really feel the wind at all. But I don't know whether it's not cold or something. For a change. Yeah, wait for something. We're going to be cold because which one? So I had some bread. Bread all from the restaurant. No, idea. Okay, expensive. Oh, very everywhere. No, but they are more expensive and also they are even towards cost of expensive concept. Oh, they are cool. They are more expensive. Because the food court, oh yeah, I think they have this sort of things. Not everything, right? Not exactly the same. Yeah. I know they have lunch, like the usual rice and all that. Yeah, they do. Right, yeah, they eat really, but then it's like so cold, so can I eat? That's cold. I think it's okay. The nowadays I told myself everything. I'm going to this time. I'll go with this time. Oh, yeah, next time I'll rush like that. Rush, yeah. Like where you don't want any option. We don't want to do it. Yeah, and then sometimes long things and more services or something. I'm ready to I can or you mean like big sample breast with it noodles, you know. Nutrition. Yeah, it's the big thing. It's noodles. I say I read on the walkway, the news report, the walkway, you know the walkway, right? The stall selling fried noodles. Okay. But it's all the trolleys, right? On the brush, right? You watch the video, right? Huh? Yeah. It was on the news. All the trolleys on the brush between brush. Early in the morning, the moon saw it. Then she videoed it and then walk day, yeah. And the last one was the cockroaches, right? This stall right now. They found the cockroaches in the front of us. There was yeah, that's right. I can't remember. Cockroaches infested the juice stall. Yeah, there was one juice stall somewhere. Okay. I read it. Mothership. I think it's quite common nowadays. Yeah, but it's dirty. I really think I want to eat more choice. No choice. Yeah, like the lunch crowd like come together. But I got one I was studying somebody, my classmate packed his own lunch. He's complaining so much. I was surprised. He said he never buy outside lunch. For home. I knew he was like that when he's like that. I have enough energy to cook and then bring out. If you can, it's worth it. Okay.
So this one brings the other formula.
Which one?
This schedule.
There's only one formula for density. What's the formula?
Yeah, I don't know.
You know the math, right? Huh? Hey, no, density. Oh, no, it's not a mistake. Hey.
Oh, wait, very fast.
Yeah. Density formula, it's not, it's a bit there.
No.
Right there.
Easier. I would think. But I don't know.
Yeah, those screw that up. Can you go back and finish the mission? But if you have any urgent questions, you can ask me also. You can just message me. Okay, can finish up. I'll send a copy to Putin and Dayman as well.
First for the past 4 months. I haven't been revising seriously.
Okay, I just start with this.
Yeah. Before it comes to the
Yeah.
iMatter. Yeah, the time of EOY right, last year, there was nothing you can do really. So I just did whatever I could.
But now you're not taking higher MLT, right? No, huh?
No.
Yeah, I mean, it's a burden off your shoulder.
And then there's more burdens on
Uh,
the people that can take higher matter and pure science and amen, don't know what to say.
yeah, you just deal with your own problems.
Got people in my class at them. But
Yeah, okay, bye-bye.